This is 7-1 bell work and 7-1's lesson on January 25th. So go ahead and write down all your bell work. There is only one question for the bell work today because you're going to see in a second why I only gave you one question. So it says select the fourth degree polynomials from the following. So we have to identify which one has a fourth degree, and I'm going to show you what that is. So fourth degree means that the highest degree or the exponent is a 4. So for part A, all you got to do is distribute the x squared in, and then FOIL the right-hand side. So first, outer, inner, last. And then we're going to combine like terms. So these three we can combine. 1x to the third plus 1x to the third plus 5x to the third is 7x to the third. And then there is no match with the blue one, so I just wrote it down. There also is no match with the green one, so I just wrote it down. And there's also no match with the negative 5x, so I just wrote it down. So now that we have all of the terms written, you're going to rearrange them so they're in order from highest degree or highest exponent to least exponent. So negative x to the fifth goes first, and then plus 7x to the third goes next because there is no fourth degree. Negative x squared goes next, and then last would be negative 5x. So now what you do is you look at the highest degree, and that is the degree of the polynomial. So this is a 5, which means it's a fifth degree, so we are not shading in A. Then for B, you're going to do the same thing, FOIL the second part, and then combine like terms. So x to the third doesn't have any matches. Negative 3x, there is no other matches. 5, we have two numbers by themselves, so 5 minus 3 is 2. Then 2x to the fourth is by itself, and negative 6x squared plus 1x squared would be negative 5x squared. So now we rearrange them to be in greatest to least. So 2x fourth plus x to the third minus 5x squared minus 3x. And that means that this is, plus 2. That means this one is a fourth degree because it has the highest exponent of 4. So B is one of them. All right, so now for part C, you're going to do the same thing. We're going to distribute xy into the parentheses and then copy down the rest of it. And now we're going to combine like terms. So we have all of these are not actually like terms. So what you do is anything that does not have an exponent, you can put a 1 there as a placeholder. And these are actually exponents where you have a term has more than one exponent, so you add them together. So 2 plus 1, 1 plus 2, 1 plus 3, 2 plus 1, and so on. So that turns that term into a third degree. That one's also a 3, that's a 4, that's a 3, and that one's just a 0, which I change later. I don't know why it says 4 right now, but it will say a 0. So actually, I don't think it does. I may change it. There. Okay, so now it's a 0. All right, so the highest degree is a 4, which means C is also a fourth degree, so C would be an answer. And then for part D, you're going to do the same thing. This is foiling, so x times y to the x, or yx, and then x times negative 2x squared, and then negative 3y squared times yx, and negative 3y squared times negative 2x squared. So now you have a bunch of different exponents. Again, if you don't have a variable with an exponent, just put 1s next to it. So now we're going to add those exponents together that have 2 or more in the same term. So 2 plus 1 is 3. That one's by itself is 3. 1 plus 3 is 4. And then 2 plus 2 is 4. So the highest exponent along those are also just 4, so that means that one's a fourth degree, so D is also one of the answers. Then the last one, we're just trying to find each term and what their degree is, so we're going to add those exponents just like before. So 2 plus 1 is 3. 3 plus 2 is 5, and 4 plus 2 is 6, so that's a sixth degree polynomial, which is not fourth degree. So the answers would just be B, C, and D. All right, so we are going to start 7-1 now, so explore and reason. Each year the Student Council conducts a food drive. At the end of the drive, the members report on items collected. Describe 2 different ways that the student can sort the items that are collected. So the food could be sorted by each category of food, like oatmeal, peas, etc., or the food could be sorted by the type of container that it comes in, like cans, bags, etc. And then B says, write 2 expressions to represent the number of type of items collected. So if we say let T equal oatmeal, M equal meat, B equal beans, C equal corn, R equals rice, and so on, and then let C equal cans and B equal bags, so then you could put down 3T plus 6P plus 3M plus 5B plus 6C plus 4R, or 20C plus 7B. So you could do it in two different ways, either by what kind of food or what kind of container. And then part C, share your experience with your classmates. How are the expressions similar? How are they different? Why are they different? So our expressions use different variables and terms. So obviously if we asked you to come up with your own, you might have used O for oatmeal or something else. And you could compare how you use different variables and the reason why. And then you would probably end up with the same coefficient but different letters. And then for example 1, why does a constant have a degree of 0? So a constant is just a number, so no variable attached to it, just like 1, 2, 3, 4, 5. So a constant, it's a monomial, which means it's only one term. So there's no plus or minus, in the middle. A monomial is a real number, a variable, or a product of a real number, and one or more variables with whole number exponents. So for example, x squared is a monomial, 2y to the third is a monomial, 4 is a monomial, 4x squared y to the third, z to the fourth is also a monomial. So it's a monomial when you have no spaces in between. And then the degree of the monomial is the sum of the exponents of the variables. So this would be a second degree. This would be a 0 degree because there is no exponent. This is a third degree. And this one is 2 plus 3 plus 4, which is a 9th degree, and so on. So you just add the exponents together, and numbers do not have exponents. So they're a 0 degree. So the variable in the monomial 15x squared has an exponent of 2, so the degree is 2. The sum of the variable exponents in the monomial 1/2 x to the fifth y squared is 7, because 5 plus 2 is 7, so it has the 7th degree. And then for part A, it says a constant has no variable. However, any number to the 0 power is equal to 1. So you can multiply a constant by x to the 0 without changing the value of the constant. So for example, 7 could have 7x to the 0 next to it, which means 7 times 1 is still 7. So that's why a constant has a degree of 0. And then it says, for example, 1b, why is 5x to the third minus 4 called a cubic binomial? So you can categorize polynomials by two different ways, either by their degree or by the terms. So degree is, again, the exponent, and terms is how many terms there are in the problem. So for example, if you look at the table down below, you can see that there's only 7, which has a 0 degree. 4x has a 1 because x doesn't have an exponent. 3x squared plus 2x plus 1 has a 2, so it's called a quadratic. Negative 5x squared and y, remember we add the exponents together, so this has a 1, which means 2 plus 1 is 3. And 3 is called cubic. The way you can remember it is a cube has 3 dimensions, length, width, and height. So that's why it's called cubic. And then the bottom one, if you add the first term, you get 4. This has 1, this has 1, this has 0, so this is a 4th degree. So constant is just a number. Linear means like y equals mx plus b, where it's just a straight line. Quadratic has a 2nd degree. Cubic has a 3rd degree. And 4th degree. After cubic, we don't say anything else other than 4th degree, 5th degree, 6th degree, and so on. And then for the next one, you can actually categorize it by its terms. So you count how many terms there are, and the prefix is what changes, and the end is just nomial after each one. So like monomial means 1 term, binomial like bicycle, 2 wheels, 2 terms, trinomial has 3, and polynomial has 4 or more. So you just count in around the plus or minus signs. So like here's 2, here's 3, here's 4, and so on. So after we get to 4 or more, there's no more names for it. It just stops after that. We just call it polynomial because poly means many. So after 4 or more, we just call them all polynomials if we want to call them by terms. So 5x to the third minus 4 is called a cubic binomial because it has the degree of 3 with 2 terms, and bi is 2, like bicycle or binocular, all those words that start with bi. All right, so try it, example number 1. So we're going to categorize it by the degree and then by the term. So we're going to add 1 and 2 together and you get 3. So it has third degree and it has 1 term. So if you remember, third degree means 3, so that's a cubic monomial because it has 1 term. Then the right-hand side for 1b, we have x and y, which is 2, so 1 plus 1 is 2, and that's only a 1, that's only a 1, so the highest degree is 2, which makes it a second degree. And there are 3 terms because they're all separated by the minus sign and then the plus, so there's 3 terms there, meaning it's a quadratic trinomial. So quadratic is the second degree, trinomial is 3 terms. And example number 2, what is it in standard form? So standard form is, all it means is you're just writing it from greatest to least. So your degree is the highest exponent goes first, and then you go in descending order. So if you're looking at this problem, you can see that the highest degree is 6x to the 4th, so that goes in front. The next highest is the 3, and then the 2, and then this one has a 1, and this one has 0. So it just goes 4, 3, 2, 1, 0, and you copy down exactly what the problem is and rearrange it. So when you move a term to a location, you have to make sure you move the sign that goes with it. So whatever sign is on the left, that goes with it when you move it. And then after you reorder it in standard form, you're done. So 4, 3, 2, 1 is the degree for each one, so you know that you have it in order from greatest to least. All right, example 2a, so write each one in standard form. Again, highest exponent first. So we're going to put that negative 3x to the 3rd in front. The negative goes with it. Then plus 6x squared, and then plus 7, and you're done. Then for part B, we're going to move negative 8y squared to the front because that has the highest exponent. Then 2y, and then negative 3, and you're done. Pretty simple. So just make sure you move whatever the sign is to the left, it goes with it. So it's like a puzzle piece. You move it with it. Don't leave it behind because then you end up with the wrong answer. All right, so this is an example video.
How can you use the properties of operations to combine like terms and write the expression 4x plus 3x squared plus 2x plus x squared plus 5 in standard form? You can use algebra tiles to model the expression. This tile has side lengths x by x, so it represents an area of x squared. This tile is x by 1, so its area is x. This tile is 1 by 1, so its area is 1. To model this expression, you can model each term one at a time. 4x needs 4x tiles. 3x squared needs 3x squared tiles. Then you need 2 more x tiles, 1 more x squared tile, and 5 ones tiles. Like terms have the same variables to the same exponents. In algebra tiles, these terms are terms modeled using the same tile. So, for example, you can combine x squared terms, but you cannot combine the x and x squared terms. Rearrange the tiles to group like terms together. There is a total of 4 x squared tiles, or 4x squared. There is a total of 6x tiles, or 6x. There is a total of 5 1 tiles, or 5. The expression 4x plus 3x squared plus 2x plus x squared plus 5, written in standard form, is 4x squared plus 6x plus 5. You can also rewrite the expression in standard form using the properties of operations. Identify the like terms. Then rearrange the terms in the expression to group like terms together. Then combine the like terms. The expression in standard form is 4x squared plus 6x plus 5.
All right, so here's 3a and 3b examples. So combining like terms. And then you put it into standard form, so greatest to least for the degree or by the exponent. Same thing. So you're looking for things that have like terms. So negative 3x goes with positive 3x, not because of the 3's, but because of how many x's it has. So you don't care about the number, you care about the variable. So x plus x, so negative 3 plus 3 is 0, so that cancels out the x term. And then 4x squared minus x squared is like 4 minus 1, which is 3x squared. And that's all the stuff that's left. And so you can't put it in standard form because there's nothing else to rearrange. For part B, you have 7y to the third and also a 5y to the third. So they both have y to the third. So 7 plus 5 is 12y to the third. And then negative 3y and negative 2y would be negative 5y, and then drop down the 7 because there's nothing else to combine with it. So the highest exponent is 3, and then 1, and then 0, so you know you have it in order from greatest to least. And that would be the answer for 1B, or 3B, sorry. And that is all for today's lesson for 7-1. So I hope you have a good day, and I will see you tomorrow.